In this video, I'm going to demonstrate how we can use division to help us factor, and I'm going to be using synthetic division throughout this, but if you prefer and you don't really care for the synthetic division, you can always use long division. So it says that if we have x equals -4 is a root. Now when you hear this word root, we could think of that as a 0, or that's really the same thing as an x-intercept. So if x equals 4 is a root, or if x equals -4 is a 0 of x cubed minus 28x minus 48 equals 0. So basically what that means is if you plug -4 in, it's a solution. It's going to make this equal to 0. So you can actually say -4 is a solution to this particular equation where it's equal to 0. Now it says we want to use synthetic division to factor the polynomial completely, and we want to list all the real solutions. So we want to factor the polynomial completely and list all the real solutions to the equation. So to do that, if -4 is a solution, then we can simply take -4 and divide that into our polynomial. And because it's a solution, we know it's going to divide evenly. So again, we want to bring down the coefficients. We have an x cubed, and notice there is no x squared, so we want to put in 0x squared as a placeholder. So we would have a 1, and then we would have 0, then a -28, and a -48. And then we're going to go through our process here. We're going to bring down the first term, which is a 1. So we bring down the 1. And then we're going to multiply here. Okay, -4 times 1 is -4. And then we're going to add 0, -4 is -4. And we're going to keep repeating this same process. We would multiply. So -4, -4 is a positive 16. And then we would add 28, -28 and 16 is going to give us a -12. And once again, we're going to multiply by the -4. So that's going to give us a positive 48. And now once we add, these two terms on the end should always cancel out if we know that the number we're dividing by here is a root, a 0, or an x-intercept. In other words, it's a solution to this equation, so it has to divide evenly. If this did not divide evenly with a remainder of a 0, then we know that we made a mistake somewhere because they are telling us that -4 is a solution. Now, once we divide, once again, we're going to decrease our exponent, which we had an x cubed here. So that means now we're going to have x squared. So we have a 1x squared, a -4x, and then our -12. So that's what we have now once we divide. So now we want to continue to factor this. Well, because this is a nice trinomial, then we can easily factor this expression because we want to factor our polynomial. So now we can continue to factor this. Well, how do we get x squared? That's simply x times x. And then for 12, we have the possibility of 1 times 12, 2 times 6, and 3 times 4. And a little bit of trial and error here. I'm going to probably go with 2 and 6. And we need a -4, so we're going to have a -6 and a +2. So there's our factors. Now, if we want to find the solutions we're talking about, then we're going to take x minus 6 and set that equal to 0. We're going to take x plus 2 and set that equal to 0. So therefore, x equals 6 and x equals a -2 are solutions. And up here above, they told us that x equals -4 is also a solution. So notice here we had a large exponent of 3, or highest exponent rather, is 3. And notice we had 3 roots. So in other words, we can call this our roots. We could think of this as our zeros. This would be your x-intercepts, or you could even say this is your solutions. So all of these are meaning the same thing. Now, they also said they want us to find the factors. Well, if this is negative 4, then that means that x plus 4, and that means that x minus 6, and then x plus 2 would represent our factors. So here we have completely factored the polynomial and we found all of the zeros. So if you were to take x plus 4, x minus 6, and x plus 2, if you were to multiply all three of these out, then you should come up with x cubed minus 28x minus 48. All right, our next example, they tell us that x equals 2/3 is a root of 48x cubed minus 80x squared plus 41x minus 6 equals 0. And again, it says use synthetic division. Again, if you prefer long division, you could certainly do that. And again, we want to factor completely and list all the real solutions. So if we're going to start off with x equals 2/3, they tell us that is a solution. So we're going to divide by our 2/3 out front. And then we want our coefficients here in descending order. So we have x cubed, x squared, x, and then our 6. So we're going to bring down the 48, negative 80, 41, and negative 6. So once again, we're going to bring the 48. That's going to come straight down. And then we're going to multiply 2/3 times 48. And that's going to give us 32. And this is where if you need your calculator, just simply take 2/3 times 48. So you get 32. And then we're going to add negative 80 and 32. That's going to be a negative 48. And then 2/3 multiplied by negative 48. That's going to give us a negative 32. We're going to add those together. 41 and negative 32 is a positive 9. And 2/3 times 9, we're going to get positive 6. And negative 6 and 6 is going to cancel out. And again, we know that this remainder has to be 0 because we are given that this is a solution. Now, once again, we have this x cubed. So that means we're going to start then with an x squared term. So we have our 48 x squared, negative 48x, and a positive 9. And once again, just like before, we want to factor this. So we want to factor this expression. And this one could be a little bit more challenging because here we have a 48. So you'd have to look at all of the factors of 48. And then we also look at all the factors of 9. Well, the factors of 48, I'm going to kind of guess here. It looks like 12x and 4x is going to work. And then for the 9, 3 times 3, and both of these would be negative. And that's going to work out because if we were to multiply the 12x and negative 3, that's going to give us 36x, and then here you would get a negative 12. So negative 36 and negative 12 gives us the negative 48x in the middle. So we could certainly then take 12x minus 3, set that equal to 0. 4x minus 3, set that equal to 0. And if we solve for x, we get x equals add 3, divide by 12. So x equals 3 into 3 is 1, 3 into 12 is 4. So we have 1/4. And then here, move the 3 over, and then divide by 4. So x equals 3/4. And from above, they already told us that x equals 2/3 was a solution as well. So here we have our zeros, or what they call our roots, or again, we could call that our x-intercepts, or simply the solution to the equation that's equal to 0. Now, we also wanted to find our factors, okay? Now, there's a couple ways we can write this. Now, kind of a quick and easy way is we could just bring this as x minus 2/3 equals 0. We could bring over the 1/4 and we'd have x minus 1/4. Okay, so we could think of that as our factors that way. And then we would have x minus 3/4. So here you could think of the factors this way, but normally you're not going to write these as a fraction here. A better way to write this as your factors would be think how you could move the 2/3 over. When we have x equals 2/3, how could we get rid of the 3 first? We could multiply, let me bring this down here. If we have x equals 2/3, we could certainly multiply by 3 on both sides. And if we do that, you'd have 3x equals 2. And then to get rid of the 2, we could subtract that. So then we would end up with 3x minus 2. And that's a better way of writing this. And we could do the same thing with the 1/4, multiply by 4, and that's going to give you 4x, and subtract the 1, so that's a -1. And then with the 3/4, we could do the same thing, multiply by 4, we get 4x, and subtract the 3, and here we would have our factors. All right, here's our next example. It's going to be very similar. It says we're using the factors x plus 3 and x minus 2. Find the remaining factor or factors of the given function, 3x cubed plus 2x squared minus 19x plus 6. So here they want us to factor this polynomial completely, and they already give us two of the factors. Well, if x plus 3 is a factor, if we set that equal to 0, then that tells us that x equals a -3 is a 0, and we can take x minus 2, set that equal to 0, and that tells us that x equals 2 is a 0. So I'm going to start. It doesn't matter which one you start with. I'm going to start with the -3. So I'm going to pull the -3 out front. And then we want to bring down our coefficients, and again, make sure they're in descending order, x cubed, x squared, x to the first. So the coefficient is 3, 2, -19, and 6. Once again, this first term comes straight down. Then you're going to multiply. -3 and 3 is going to give us a -9. 2 and -9 is -7. -3, -7 is a positive 21. -19 and 21 added is going to be 2. -3 and 2 is a -6. And once again, we know this better be a remainder of 0. Now, keep in mind, we had an x cubed to begin with, so that means our first term here is going to be an x squared. So that means we would have 3x squared minus 7x plus 2. Now, at this point, we have an option here. We could actually go over here and we could factor this trinomial. We simply have 3x squared minus 7x plus 2. We could factor this as 3x and x is 3x squared. And then 2 would be, looks like -1 and -2. So we could certainly do that. Or we could, because they already give us that x minus 2 as a factor up here in the problem, if we use the x equals 2 now, we could continue to divide. So I'm going to put the 2 out front, and now we're going to use the 3, the -7, and the 2, and we can use our synthetic division. Once again, bring the 3 straight down. 2 times 3 is 6. -7 and 6 is -1. And 2 and -1 gives us a -2, which our remainder is 0. Now our exponent up here was x squared. So that means now we're going to have x to the first. So our coefficient here is 3x, and then we have minus 1. So we could take the 3x minus 1, set that equal to 0, move the 1 over, divide by 3, so we would end up with x equals 1/3. And from the beginning, they told us what? X equals -3 and x equals 2. We used x equals -3, x equals 2. So if we wanted to identify here, this is the roots or the zeros of the function. And then, of course, the factors would be x plus 3, which was given, and x minus 2. And we just found here the 3x minus 1. Again, multiply by 3, so that's 3x, bring over the 1, so the 3x minus 1, or we can simply get it from above. So there we have completely factored the polynomial function. Now for the last example we have here, it says using the factors x plus 2 and x minus 4, once again we want to find the remaining factors of the following function. So if x plus 2 is a factor, then we can set that equal to 0, and we can look at x equals negative 2, and then we could take x minus 4, we set that equal to 0, so we get x equals positive 4. So again, you could start with either one of these. I'm going to start with the negative 2, so I'm going to put the negative 2 out front, and then we're going to bring down the coefficients of our function, 8, negative 14, negative 71, negative 10, and a positive 24. And again, make sure they're in descending order. X to the fourth, x cubed, x squared, x to the first. So first I'm going to bring the 8 straight down, and then we have negative 2 times 8, which is a negative 16. Negative 14, negative 16 is a negative 30. Negative 2 times negative 30 is a positive 60. And negative 71 and 60 is a negative 11. Negative 2, negative 11 is a positive 22. Negative 10 and 22 is 12. And of course, negative 2 and 12, we end up with our negative 24. So the last two cancel out with a remainder of 0. Now, once again, we started here with an x to the fourth. So that means here this would technically drop down to x to the third. And our coefficient would be 8x cubed. And then we'd have a minus 30x squared minus 11x and our plus 12. Now, we know that x equals 4, so now we can divide by 4. So I'm going to bring the 4 out front, and then I'm going to bring down the coefficients of what we have now is 8, negative 30, negative 11, and positive 12. Once again, we bring the first term straight down, so we have our 8. 4 times 8 is 32. Negative 30 and 32 is a positive 2. 4 times 2 is 8. Negative 11 and 8 is a negative 3. And 4 times negative 3 is a negative 12. And again, our remainder is 0. Well, now we started with x cubed, so we're going to decrease that once again by 1. So we now have x squared, and our first number is 8. So we have 8x squared plus 2x minus our 3. Now at this point, we have a nice trinomial that we can factor, so we could easily factor this hopefully. To get the 8x squared, I'm going to start off and try to use 4x and 2x. And really the only option for the negative 3 would be 3 and 1. And it looks like we're going to put the 3 here and the 1 here and make this a positive 3 and a negative 1. And let's see, if we multiply here, how are we going to get the 2x? Well, we're going to get here is a negative 4x. 3 and 2 is 6x. So 6x minus 4x does give us the positive 2x. So it looks like from above, the two given factors were x plus 2 and x minus 4. So we had x plus 2 and x minus 4. And now we have the factors 4x plus 3 and 2x minus 1. So here we have completely factored the polynomial function. And if you wanted to find the zeros, we could certainly just set each one of these equal to 0, and you could find the zeros are the roots for this particular function.